guys, this is Ashley here at Jackson Systems, and we are live doing our training at the JSU. And for everybody online, I want to thank you for coming and joining us here today. And of course, don't forget, if you have any questions while we're doing the training, definitely stop and go to your Q&A box, and we'll be able to answer those for you. And here, our special guest tonight is Eric. Hey,
Thanks,
Eric,
Ashley.
how are you doing today?
Good. How are you?
All right, so what special treat do you have for us today?
All right, well, tonight we are going to talk about Solderweld, and we're going to do some actual coil repairs. In the service engineering video that I did earlier on, we did a repair on our tube and fin coil right here.
Oh, that looks a little rough.
Yeah, I mean, it's had some repairs doing it, and I've done a lot of training on this, so, you know, we're doing some education out here on this. Tonight we're going to talk a little bit about the strength, because I get a lot of questions about how strong is this material. So I'm going to show you how strong this material is. It's actually stronger than the parent aluminum, so it's a very strong material once it gets attached. And then tonight we're going to talk about our microchannel coils. All right, so we're going to take a look at microchannel. We're actually going to make a repair on a microchannel. I'm going to show you how to do that, as well as then we're going to talk about Hotblock, what it can do for you, and we're going to do a demonstration on actually comparing it to just a rag that's been wetted with water. So
all right, perfect. So I hear a lot of hands-on that we're doing tonight.
A lot of hands-on here tonight. We're a lot of show and tell. Not really any slides. I'm sorry, guys.
I think they're going to be good with that. So, all right, guys. Well, like I said before, if you have any questions while during this presentation, hit that Q&A box, and we'll be able to answer them for you. All right, Eric.
We love questions.
Take it away.
Thank you very much, Ashley. All right, folks. So tonight, let's start out with we're going to do a little bit of strength testing here. So I'm going to weld up a spot in this aluminum tube. Let me get this big coil out of the way here so we don't have to deal with it, because we're not really going to work with it tonight. So we're going to fix a spot in one of these holes on this tube, and then what I'm going to do is I'm going to take a standard scratch awl and we're going to hit that spot where I repaired it just to see how strong that is and if I can punch through that. Now, I can punch through it eventually, but it's a whole lot easier to punch through the aluminum than it is the weld. So to do that, we're going to use the alloy sol product, all right, with the flux. And on this tube, we're just going to use a propane torch. Now, the alloy sol product melts at 600 degrees. The parent metal aluminum melts around 1200 degrees Fahrenheit. So we're at half the melting temperature when we're working with the alloy sol product on the aluminum. You do still have to be careful on aluminum because it will melt really quickly. So you have to be careful. You have to keep the flame moving. If you leave the flame in one spot too long, you're going to melt a hole in it. It happens every once in a while. However, working with tubing is actually more difficult than when we're working on a coil, because a coil will dissipate that heat. So when we switch to making a coil repair, you'll see me switch up to a hotter torch, something that puts a little bit more heat into it so that we can combat the fact that that coil is dissipating and transferring the heat away from where we're trying to make our joint at. So let's get this going. To start out with, we're going to heat up our rod. All right, we're going to dip it in the flux. We have a paste type or a powder type flux here. It turns into a paste when the rod is inserted into it. It sticks to the rod, and then we'll melt it down onto the hole that we're going to repair here. Now, when we zoom in, hopefully you guys can see this watching, you're going to watch that paste flux start to melt, and when you start to see the hole appear in the middle of the flux, that's when you're going to be ready to start applying the rod to it and melting the rod into the hole. So our flux stuck in on the rod. Cool our rod down. Now, when you get done with this, you need to let, anytime you do aluminum is especially important, you need to actually let it cool naturally. If you don't let it cool naturally, if you put water on that right away, you're going to put stress cracks in that aluminum and you're going to cause that aluminum to crystallize somewhat, making that aluminum a weaker substance right around that weld metal. So we really don't want to do that. We need to let it cool off a little bit, but once it gets cooled down a little bit, we need to clean that. We got to get any excess flux off the outside of that joint, okay? And the way you do that is using a dedicated stainless steel brush. So with the Solderweld kits, we send a stainless steel brush with those kits. Use that brush only for cleaning up your aluminum. If you go to use it for, say, steel or something like that, and you get steel particles embedded in this, when you go to scratch that aluminum later, you're going to transfer some of that steel over to the aluminum, and then you're going to have more problems with your aluminum later on down the road because you're going to cause corrosion on it. Question, yes? Why is it important to clean off the excess flux? So this flux is slightly acidic, all right, to clean the surface of the aluminum. That's a very great question. Okay, so the question was, why do we need to clean the flux off? Okay, the flux has to be slightly acidic because when you have bare aluminum open to the atmosphere, it starts oxidizing immediately. And we have to get through that oxidization to make the actual filler metal stick to it. All right, so we should be cooled down pretty good here. Fairly thin leather gloves so I can feel. There's still a little bit of heat in there, but we're pretty cool. So take a little bit of water on the stainless brush, brush it off, clean it off. Shine it up, and there's a nice repair. You can see it right there in that joint, in that hole that I had in there. So what we're going to do with this, let's lay that down on top of here, if I can get it to stay. And I'm going to hit that new metal with an awl, and I had, there we go. This is also used as a hammer. Everybody knows that, right? Any tool can be the right tool for the job. You just have to find it. Hold this all in place. And hitting that metal, you're going to see I dented that metal. Yeah, I put a little scratch in it there, but I didn't go through it. Now, if I move over and hit that about the same on the aluminum, I went right through that aluminum. Okay? Yes, question.
So this is from Mike from Air Left, and he is asking, can you use MAP gas?
Yes, absolutely. Again, with that, you need to select the torch for the material that you're working on and how fast it's going to dissipate heat. On this type of a repair, in a piece of tubing, MAP gas is a great tool to use. When you get into things like coils, MAP gas is not going to create quite enough heat to adequately fix that coil and heat the metal of the coil because of the heat dissipation out of it. I prefer, when I get into a coil, to either use an air acetylene torch or an oxygen acetylene torch with a fairly small tip in it. You need to be able to control the heat in there, but you don't want to put the MAP gas on it because it's not going to heat it fast enough.
And then there's another question from Ronald from West Shore Heating. He asked, do you need to trickle nitrogen through, like when brazing copper tubing, to avoid scale buildup inside?
Very good question. The answer is absolutely yes. Because we can get hot enough to oxidize in there and create that oxidization, that is a very good question. Yes, always, always purge nitrogen when you're repairing a system. Thank you for asking that question. Very good. So, any other questions on the strengths? Okay. That's one I've been getting asked quite a bit lately. Now, let's take a look. Yes, sir.
Which product were you using there?
That was the alloy sol.
The alloy sol.
Yeah, alloy sol.
Does that come in that repair
Yes, that is in the aluminum, in the small aluminum repair kit. That's one of the two. The other piece in there is the ACRTB braze, which is for joining the aluminum to copper, which we just covered in the service engineering video as well earlier. So if you guys want to go back and see the ACRTB braze, go back and look at that service engineering video.
Have another question from
Okay.
Mr. Stanley at Stanley Heating. He asked, is there a different technique to solder overhead pipe, or from the top, or horizontal, vertical?
Not really a whole lot of different technique, because this is going to work with capillary action to stick to that pipe. You may have a little bit of dripping, but you're really not getting hot enough to where it's just going to run off and fall down. If you have something that is right on the bottom of the pipe, I'm not going to say it's not going to be more challenging than doing like a vertical pipe or a horizontal pipe where it's on top or the side, but you should still be able to get up there and do that. Lots of good questions. Anything else right now? Sweet. So the next thing I wanted to look at here is actually microchannel coils, okay? And if you haven't seen or gotten the chance to work with microchannel coils yet, they're a little bit different. And what they have, I'll flip this around here. Microchannel coil has a header on both sides of it. This is a piece that's cut out of one. It's similar to an automotive radiator. Okay, so we bring everything in a header on one side, we transfer it one pass through the coil, and it goes out the header on the other end. Inside that coil, each one of these tubes in here has a ton of little tiny passages. This particular coil, you can see here on a tape measure, it's about an inch across. Okay, the tubes are about an inch wide. I counted earlier because I was curious. I'd never counted them. There's 34 passages in one of those tubes. So there's a lot of little tiny passages in there. And this is one place that is very important. I don't care whether you're working on aluminum or copper, to purge your nitrogen. It makes it doubly important to purge because those passages can get plugged up with anything. But it's a little bit different to repair because it's aluminum, and they can be challenging to repair. Now you can see couple spots on here on this one that I've repaired. Now obviously I can't pressure test this one afterwards. It's got some physical limitations that won't allow us to pressure test that one. However, we have another coil over here that we can pressure test. So what I've done is I've got a hole actually cut in this coil, gently cut in the coil, kind of mimicking a rub out like you would see in the field. And we'll just apply a little nitrogen pressure here to this. Okay, I'll put a couple bubbles on it and you can see where the hole is at here. And let's get, I got too much pressure on it already. There you can see the bubbles coming out. Can you see that in there? A little bit. I'm checking with the camera guys in the back to make sure they can see everything in here for you. Try to make sure you can see this on here, because it is bubbling quite a bit. If you can see that around the edge right here, there's a little bit of bubbling in. There we go. You really see that coming out. It's a really small hole that's going to let all your refrigerant out pretty quickly. So we need to be able to fix that. So again, with this product, we can do that. You can see I've got another repair here done on this one. This is one of the coils that I use for training as we go around to different places. Again, we're going to use the alloy saw for this. I'm going to use a little bit larger torch though, because of the heat dissipation of this coil. I have a lot of surface area here that gets rid of heat really quick. So you need to go in with something a little bit hotter to even get this heated up enough to make the rod stick to it. And you really need to have very, very low nitrogen pressure on there. I'm not going to purge because this coil's never going back into service. It's simply for demonstration purposes on this. But if I were to fix this in the field, if I'm working on this out in the field, fixing it for a customer, absolutely I'm going to be purging nitrogen. Okay, so we're dealing right here where that scratch is. That's where our hole is in here. And for this one, I'm going to use a number 3 tip on an air acetylene torch. I found this to be a really nice tip for the microchannel coils. Every once in a while, if I'm going into a really big coil, I may even step up to a number 5 tip, but normally the number 3 I've found to be a pretty good size for this. Now, anybody notice something that I didn't do a whole lot of before I put that on there? I didn't do a whole lot of cleaning on it, right? That's what the flux is for. Light coats like of the soap, and you saw the soap coming up off here, that's what's steaming on here. I had the bubble detection solution on there. That flux going on there is going to clean that surface and clean right around that joint to make sure that the metal and everything sticks to it. That's the job of that flux. And I think we've got a pretty good repair on that one. Now again, you want to let this cool for a little while for maximum strength. I'm going to cool it a little bit quicker here for time reasons, but it's cooled out quite a bit already. I didn't even get any hissing when I put the water on it. So let's see how good we did on our first repair there. As with anything, sometimes it's hard to see if you actually repaired it until you put some pressure on it. So pressurize it gently to start with. We're going to listen. Add a little soap, see if we get anything out of it. Got nothing. So let's take our pressure up a little bit here.
What if you didn't get it completely repaired? Can you just go right back and
Yep, just go back in, add some more flux on top of it.
Eric, can you repeat the question, please?
Yes, okay. Question was, what if you didn't get it repaired the first time? And all you do is you add a little bit more flux on top of that and add a little bit more rod to it and just fix right over top of whatever you did on there before. So there's 500 PSI at it. No hissing, no noise. No bubbles. So that's a really fast and easy way to make a repair in a damaged microchannel coil. You can do that on condensers. Obviously, this is an evaporator. Multiple different types of things that you can make repairs on there. So.
What kind of applications would you see those in?
They're in all kinds of different air conditioning systems. Okay, so we're asking about applications. What kind of applications we see this in? This is a residential application right here where I got that coil. They're in a lot of commercial, they're in industrial things. They're all over the industry today and they're becoming more popular. The big reasons being that they reduce the amount of refrigerant that the equipment holds, and they're also more efficient than a standard coil because they transfer the heat faster because of the way that they're designed. So there's a couple different reasons. So let's get this hose empty here. Get this back down on the table. Any questions so far? Yes, sir.
Is there a specific PSI that you have to reach for it to be well tested?
So the question is there a specific test pressure? Yes, and it's typically whatever the coil is rated for. All right, so if I looked on this coil, this regulator that I have was rated at 500 PSI. The coil test pressure on this one is 665 PSI is what the coil is rated at. Typically, I look for the high pressure switch limit, something like that. On this, if it's going to hold 500, chances are it's going to hold 665. The metal itself, the joint, or the metal that goes into the joint itself is rated at 30,000 PSI. So it's a very strong material, much stronger than the aluminum. Okay, any other questions for now? All right, sweet. Now, when we move on here, we're going to switch things up a little bit. And switch our tip over. I'm going to switch to a little bit bigger tip. All right, we're going to go up to an 8 size here. This was something I started playing around with. The Hotblock product. I wanted to know, because I've used just regular old rags soaked with water, was what I started using out in the field. And I wanted to know what the difference was between a heat blocking paste and a wet rag. So I went out and started playing with it. And what we've got here is a thermometer, which will turn on. Can you see that?
We got a request. Could you do it right in the middle of the table, please?
Yeah. Let me move that over. Absolutely. What's the question?
So we have another question from, and if I pronounce this wrong, I do apologize. It's Nam from Namir Enterprises, and he is asking to how many ton capacity those microchannel coils are available on the market.
I have seen them all the way up into large commercial chillers, as well as dry coolers. So pretty much anything that's an air-cooled device is going to use them as far as where you're cooling your refrigerant.
And another question from Ronald from West Shore. He said, I have a 1-year-old evaporator coil where that is leaking on a U-bend. The entire circumference, like it blew loose. Do I need to remove the U-bend and clean the end, or socket before using
Alloy sol.
The alloy sol.
Yes.
So the alloy sol. Let me pull something back up here to answer that question. And I want to make sure that we're talking about the right spot on the coil to answer his question properly. And I'm not sure I've ever seen a failure there yet. I'm thinking that he's talking about on this U-bend, the joint right here where it's soldered into the end of the coil tube. Okay, so we're talking about the whole circumference around here. I would say flux it. I would not try to pull it out. I would flux it, let that flux do its job, and add the alloy salt back onto it and pressure test it really well. All right, got that question answered. Good. Okay, so let's move on to some Hotblock. So we got 2 K-type thermocouples on each end of this. The Hotblock product comes as it's kind of a paste, I guess you'd call it. And all you do is take it, lay it on here, form it around the line or whatever valve, whatever you're going to be working on. You can form it to all kinds of different shapes.
Why would you use this? What's the main purpose of the hot block for?
So the hot block stops heat transfer. And when you're working around components such as an expansion valve, something that's got gaskets in it, or different kinds of seals, you don't want to heat them up to melt them. So, and the question was, why would you use this? What components do you want to protect?
Another question.
Yes, Ashley's got another question from online.
All right, Mike again. And he says, I have seen the York units leak a lot on the connection at condenser from aluminum to copper.
Mm-hmm.
If I use the Alcop, sorry,
Yep.
do I need to cut the joint out to repair it, or can I just go over it?
I'm not sure what they have in there from the factory. I would recommend on that actually cutting that joint out and replacing it. And when you make that joint, you want to make the joint so that the aluminum goes outside of the copper. And that's a good question. So when you make a joint on a pipe, you want to flare the end of that pipe out. If this is the aluminum pipe, and pardon me, I'm not very good at art. And then you've got your copper pipe that's going to slide inside, okay? And you want to make that joint in between there. Heat the copper pipe up back here. The Alcop braze is actually a brazing product, where your alloy sol is a soldering product because of the temperature difference. You're going to heat your copper pipe up back here. It's going to carry the heat up, and you're going to lay the Alcop braze rod, which is a channel flux rod. It has a flux laid in a channel, and it's a flat rod. You lay that flux down on this joint, and that's where you apply it at. So it melts the flux in first, and then it melts the rod in afterwards. Okay? Ashley, yes.
And another question from Ricardo from UEI College. He's asking, can I handle a R410A refrigerant, which has a high pressure of 400% 2B PSI?
Yes, this works fine for 410. You know, like on this one, we just pressurized that to 500 PSI, and I've had them higher than that.
Another question?
Yes.
From Mike again. And he is asking, so would you swage the aluminum?
Yes, I would swage the aluminum. Absolutely. I've heard good things about the rotary swagers. I use a little hand swager like this, which is what's called a pliers type swager. And all you do is it expands the tube out right here, and you move it around in that tube and keep expanding it out. You need to be careful, go slow on aluminum because it is a softer metal, and you can crack it much easier. Yes, sir.
Alcop video, you made that one earlier, right? They can watch that one?
Yes, the Alcop is part of the, so the question was about the Alcop video. There is an Alcop video on the service engineering videos. Yes, that was part of that one where we did an aluminum to copper joint. Oh.
Oh.
Yeah.
No, not you.
Yeah, I did. Because I asked where, he was asking where the video was.
Just watch all
They got
of our videos. Go to YouTube. Right.
They're giving me heck because I'm forgetting to re-ask the questions so you guys online can all hear it. So we got a wet rag here. You know, it's got some water in it. And what we're going to do is wrap that right around here. All right. Pretty good amount of water in there. Again, 2 thermocouple probes just taped on the line. Number 1, so the top number is going to be your hot block, and the bottom number is going to be your water-soaked rag. Got a good view on that? Excellent. What we're going to do is we're going to heat this up to cherry, and I'm just going to hold it at cherry for a little while. And we'll watch the temperatures go up, watch them come down, and see where they go. Can't even see the numbers on the back side of that. So we're actually going to we got it going backwards today. So see, I did this 3 times the other day, every time our Hotblock. Now watch, I do it 1 time on live TV, and the Hotblock is actually letting it get a little bit hotter. What I found in all my testing while I was doing this, before I set this up, see what happens when you go on live TV and try things? Doesn't always work the way you think it's going to. Was that the Hotblock would last longer, and I would end up getting the water would boil out of my rag every time. So today, I must not have that Hotblock wrapped on there very well today. This is one thing with this product, you need to get a good, tight hold on it in order to stop the heat transfer, because you have to have the surface contact with it. If it doesn't have the surface contact, just like with the water or the wet rag, if it doesn't have surface contact on there, it's not going to stop the heat from transferring through there. But as you can see, both of them do really well. Now the Hotblock is 100% reusable, so all I got to do is pull that back off of there, throw that back in the jar. I don't have to deal with carrying buckets of water around all the time, things like that. Question, 2 questions.
So the first one is from Mr. Stanley.
Yes.
And he's asking, I've never seen this yet, but can aluminum to steel pipes joint together?
Aluminum to steel pipes. We have a product that can do dissimilar metals. I have not tried it on tubing between aluminum and steel yet.
All right. And then the second question is from Mike, and he wants to know, does the Hotblock lose its effectiveness after so many uses?
All you got to do is add water. Yes, it will start to lose its effectiveness when it dries out. So it will eventually start to dry out over time. So all you do is you add a little bit of water back to the tub and reconstitute it. Okay? Other than that, it's good. As long as it's flexible and pliable and a little bit damp, it holds and continues to work. So, didn't work exactly like I had planned, but it does stop the heat transfer quite a bit. Like I said, I've used it now quite a bit, and I'm real happy with the products. Any other questions on there? No, man, you guys aren't asking very many questions tonight. Anyway, so show you a couple ways that you can get this. Hotblock comes in tubs. The tech repair bag is probably one of our favorite products that we end up selling. In that bag, you get the alloy sol and the Alcop braze in small tubes. You also get the alloy sol flux, as well as a small brush. There's a rag in there and an instruction card for you as well.
And the bag.
And the bag, that's correct. Now, in the all-in-one kit, this is pretty much everything that a normal service tech is going to need in most cases. And in this, you've got Alcop braze, you have alloy sol rod, you have either 5 or 15% on your Silphos rod, as well as a 56% flux Silphos rod. That one is good for steel to copper joints, especially good for compressors because it has a little higher ductility, so the discharge line on compressors is great with that Silphos 15, or Silphos 56, I'm sorry. And you also get the flux in that for the alloy sol, as well as your stainless steel brush. The other thing that I really like about these rod holders is they're all twist apart. So they do hold together positively. They're not just going to dump your rods out of the end of them. Believe me, I spent my time in a service truck, and when you've got rods dumping all over the place, it makes it really hard sometimes to keep going or find what you need. So, any other questions coming in there? All right. Yes.
Am I right to say that you guys have a tutorial type thing on Blue Hawk? Is that right? Okay.
Okay.
I thought I saw it.
Okay. So, the question was about an online tutorial for Blue Hawk members. Okay. Yeah. I don't know. Most people aren't going to have access to that. That's going to be an internal piece for you guys. Yeah. Yes. Another question.
This is from Daniel from CNC. He's asking, what is your opinion on the product Heat Be Gone?
Heat Be Gone. I don't really have one because I've never used it. I've never even heard of that one.
Okay.
Sorry, Daniel. I can't help you much right there. So, if we don't have any questions, what I'd like to do is invite anybody that wants to come up and actually try some of the products. I'll set up one of the aluminum tubes and actually get your hands on that. If you guys online can watch, you can actually see somebody besides me do it if you'd like. All right, we've got a contestant.
Pyro up is the most logical person to be doing this.
Right?
I got the fire department on speed dial.
Do we
Fire
have a
department on
fire
speed dial?
extinguisher nearby?
I got a bucket of water here. What
Hey,
more do you need?
okay, yeah, that works. All right, let's do this.
Yeah, we got some fire extinguishers nearby.
Tom, if I burn down this area, I do apologize. Please do not take it out of my check.
Okay, so what we're going to do here, I'm going to set you up with the tube.
Okay.
All right, and where did I lay? Oh, right there in front of me.
Torch.
Give you a torch, some glasses,
Is there a hole in there?
some gloves. Yeah, there's a whole bunch of holes
Whole
drilled down
bunch.
in there.
Okay.
So you got some flux. I'm opening up the wrong can of flux.
We have a couple questions.
Couple questions.
There's a question from Ronald from West Shore Heating. Hotblock, is it similar to a wet rag product?
Yes.
Repeat his question.
Question was, I'm sorry, he doesn't have a microphone on. Question was, is the Hotblock similar to wet rag product? Yes, it is similar in the way that works.
And there's another question from Mark Baxter, CBRE, Wells Fargo. How does it stand up to cool gel?
Okay, so stand up as far as works compared to cool gel. I haven't done a head-to-head comparison between cool gel and the Hotblock product, so I really can't speak to that.
And one more question from Mike Wiley at Air Left. He asked, if we can get free samples.
Free samples? Okay, so Mike wants to know if we can get free samples. I have no control over that. Call Jackson Systems.
Call Jackson Systems, get a hold of your rep, and get a good deal on this.
Okay.
That's what you guys need to do.
There you go. Call Jackson Systems. You want some gloves too?
Nah.
Okay.
Oh, yeah. Okay. Okay. The boss is saying put on the gloves. Okay.
I can't work, my hands are on fire. Can't make these calls.
All right. Gloves are on. Safety on. Okay? Safety first, ladies and gentlemen.
All right. To ignite the torch, you ever ignited one of these?
Yes.
Okay, so you know
Well,
how.
not this big.
Okay, so what you're going to do is just squeeze it a little, listen for that, and then hold it down.
Okay.
Once you release it, the flame's going to go away.
Okay.
All right, easy enough.
Sorry.
So get the rod a little warm,
Okay.
dip it in the flux, get some flux on there. It'll kind of cake on there.
Okay.
And then you want to melt that flux down into right on top of one of the holes.
Okay.
All right, let it sit on there. Once that clears up and you start to see that hole, then you're going to start to apply the rod. You want to keep the flame, you don't want to get the flame right
On
up here
it?
on top of it. You
Okay.
want to keep it back here because you have better control of it.
Okay.
All right? Don't shut the flame off. Just pull it back a little bit more.
Okay.
And move it from side to side. That'll keep your flame control and keep your heat control on the metal.
So heat this.
Yep. Heat
Dip
that
this.
up. Dip that.
Doing
Apply
deal.
the flux
Okay.
with the flame on it because that melts the flux down into
Okay.
it. Okay.
All right.
Then heat it up a little bit more. I'm going to move this back out of the way so you don't melt my meter.
Now, if I can do this, anybody can do this. So just saying that right now. Heat this up a little bit.
I think you can do it.
Dab that in there a little bit.
Little more
Oh,
heat on
little-
there. Yep,
little-
little more heat.
Little more heat.
There you go. There you go. Yeah, that should work.
Okay. You're gonna put that on there.
Yep. Okay, you got it melting.
Yeah.
Keep going. You got to keep it warm. All right. Let that come off the end of your rod. And we're gonna have to put some more flux on there now.
Okay.
Yep. Heat this back up. There you go. That should be good. Oh, okay. So what you're doing here is you got your heat too far back on the rod.
Okay.
All right. Heat your metal up. You still got a lot of flux on there, but your flux isn't melting. So
Okay.
heat the tube up right here, and then put the rod in when that flux really starts flowing away. All right.
Heat a little bit.
There you go.
And ladies and gentlemen, this is why I don't do this for a living. So we're gonna have the professionals do this.
Let's see.
you may.
that work?
have done it. Yep.
Oh, I did.
You may have gotten it done.
Close.
No, the hole's still there.
There is a little bit of a hole there, but you got some of it filled in.
Okay. Justin, you want to try? Let's try this. That was a lot harder than I expected. Oh, wait. You probably want the gloves first.
Yeah.
Just take
Sorry.
this. We'll
just
cool
hold on
that
to
off.
the hot rod. Now, the fact that you have to control that bubbling, that's a technique in itself.
Just a suggestion for you. Flip that around and hold it like that. You'll probably have easier control.
Let's heat this up for a few seconds.
Yep, heat that up for a few seconds, then just dip it
Then
down.
dip.
Oh, I see. So,
It'll stick
Is that
to it.
alright?
Yep, that's good.
okay. Now heat this up.
Yep, put the flux down in there right now because you're going to heat that flux. You're going to let it flow. There you go. All right, now start applying your rod.
Hard to do left-handed.
No, you got her.
That it?
Yep, you got it. Let it cool. There you go.
Oh, Justin got it. Yeah.
All right.
It's difficult to do, but I mean, that's what you guys go through all the time, right?
Yeah, I mean,
This is what training is for.
that's right.
To do
Got a couple
this.
questions here. From Constantino at Constantino Sampala. How your solder welds are or not toxic to use on fixing commercial aluminum back pans with just washed away will clean and acid toxic.
So we're trying to fix aluminum back pans on what type of a situation? I'm not sure. An aluminum back pan on what?
I think his question was if it was toxic or not to use on fixing aluminum back pans.
If the
Commercial.
material itself or if the flux is toxic?
Solder rods.
For that, I'm going to refer you to the MSDS sheet. That it should be on the it should be on there as a download. I believe that I saw that in the downloads earlier. So look at the SDS or the MSDS sheet, and that should give you that information. I don't have that memorized. I'm sorry.
Okay. And Daniel from CNC Myers asks, when soldering aluminum, should you still run nitrogen through the system?
Absolutely, yes. Yes, the question was, should we run nitrogen through the system when soldering aluminum? Absolutely. Whenever you're fixing a system that's going to be put into service and you're heating it up at all, always run nitrogen through it. Anytime you're heating anything on there, because you don't want any oxides to develop inside that if you have any kind of oxygen.
Leon wants to thank you for the class, and he's going to email you to show you what wet rags are.
Sounds good. Thanks, Leon. Leon's going to send me an email.
Bear Stanley at Stanley Heating and Cooling. What's the biggest hole that we can repair on aluminum pipe before we consider replacing the damaged piece of pipe?
Okay, so the question is, what's the biggest hole that you can fix? That's really going to depend on you and how much time you want to spend on it. I have filled up to probably between 1/4 and 5/16 holes successfully with it. I really haven't tried anything bigger than that, so I really can't say. The first time I tried it, I melted a big old hole in the side of the tubing, and being as, you know, okay, I've already screwed the tubing up, let's see if I can fix it. And I was actually able to fix it. So, you know, you have to do a little bit of building and working with it just like you would with a brazing rod, but I was actually able to build with it.
So it's safe to say we can't use this to cover up the holes in the streets of Indy right now, especially, right? That'd be a little bit too much?
I think that might be a little bit too
Little
much.
too big?
Yeah.
Okay, all
We
right.
got some pretty big holes around here,
we do. We got
unfortunately.
manholes, got caves in the streets. So, man, I thought that was going to be a quick fix.
It was worth a shot. It was worth a shot.
All right. So, do we have any more questions coming up? All right. All right, Eric. I want to thank you so much for doing this presentation live, hands-on. This
thanks
is
for
really
having me
fun, and for reminding me that I need to stick to making these calls and helping out our contractors out there. So, just a reminder, you guys, if you are NATE certified, please put in your NATE certification number into the Q&A so then we can get you guys certified, get you credit for that. And then, of course, if you have additional information or additional questions, then shoot us the email, give us a call, and we'll be able to answer those for you. Oh, and we got one more. Hold on one second.
John from Comfort Master. Rather than a hole, if the aluminum pipe was damaged, could I cut into it out of the sewage one end and use this product?
Say that again. I did.
Rather than a hole, if the aluminum pipe was damaged, could I cut it out sewage?
Swage it?
Yeah, it says sewage.
Oh, cut it out and swage it?
One end and use this product.
Okay, so this product there's a different product called alloy braze that's going to be better for joining the two aluminum tubes than the alloy sol is. The alloy sol is more for repairing, where the alloy braze would be actually for making that swage joint in aluminum to aluminum. I think that answers his question, because he's asking about pulling out a piece of aluminum tubing and replacing it with another piece of tubing with a swage joint.
All right.
All right.
Okay. All right, Eric. Well, it was always a pleasure you being here. Hopefully
Thanks, Ashley.
You come back soon again. And then, of course, if you guys have any questions, call Jackson Systems or you can call your rep. We also have our CSEs that are on standby waiting to help you guys out. So Q&A for your NATE certification, and I hope you guys have a wonderful night. Thanks, guys.